today we're going to turn right back around and integrate using those formulas. The good news is that really they're the same formulas, and you only need to know 3 of them because if they're, remember that the difference between the derivative of arc sine and the derivative of arc cosine is just a negative. So if there's a negative in your integral, you just pull the negative out and treat it like an arc sine instead of an arc cosine. So there are only 3 to memorize. You are going to use a u substitution here, and basically you just need to first figure out which one of these 3 formulas the integration fits. For all of these, a is a constant, and then u is your variable. So basically we have a constant minus a variable squared under a square root. So which one of those 3 is it probably going to be? Arc sine. Good. All right, so I'm going to let u, what would u be? It would just be x, right, because the formula for arc sine is the integral of du over the square root of a squared minus u squared. So basically whatever your variable is that's squared, that's your u. So u is just, and actually u is not even x squared. U is just plain old x, because in the formula it's u squared. Does that make sense? So what's du? Yeah, dx. Okay, you're right. You're not really changing anything around here, but I'm just kind of trying to get you used to using the u substitution, which you're going to need to do in most problems. So if you don't want to do it on this problem, you don't have to, but I just think it's easier to start out this way. All right, so, and then what would your a be? 2. Good. And I don't need to take the derivative of a. I just need to just kind of identify what a is. So I'm going to rewrite this using u's and a's. So dx is du, and if you want, you could write it as 1 over the square root of a squared minus u squared, and then stick the du out in front. I mean, not in front, over to the side instead of putting it up on the numerator. So this is going to be the arc sine of u over a plus c. And then you fill in your u and your a. So it's the arc sine of x over 2 plus c. Okay. Now that one was kind of, there wasn't, I guess you didn't really have to have the u substitution here, but I just kind of wanted to talk you through it. All right, number 2. There's no square root in the bottom. So which one of these 3 does it look most like? Arctan. Good. What would your u be? 3x. Very good. This whole 9x squared represents u squared. So u would just be 3x. What's a? Square root of 2. Good. All right, so this is going to be, and always, if you find u, always find du. What would du be? 3dx. So I'm going to need a 3 and therefore a 1/3 out in front. So 1/3, 1 over a squared plus u squared du. Everybody okay? All right, so my arctan is 1 over a, arctan u over a, but I still have that 1/3 out in front. So 1 over a, arctan, u over a, plus c. And I'm going to distribute the 1/3 and plug in my a and my u at the same time. So I'm going to get 1 over 3 root 2, arctan, 3x over root 2 plus c. If you can skip those 2 steps, I'm totally cool with that. The only thing that concerns me is missing the du if it's something other than plain old dx. But as long as you put the 3 in here and then the 1/3 out there, I'm totally okay with you going to the final answer. Okay, 3. What does that one look most like? The first one? Okay, the first one is arc sine, and on the bottom you have the square root of a squared minus u squared for arc sine, where a is the constant and u is the variable. But now we have the variable squared minus the constant squared. The third one, right, but the problem is that we don't have the third one has another number out in front. It has a u out in front. So is that a problem? Or do we want to just start by, what would we let u be? E to the x. And therefore, what's du? Okay, the way that we got e to the x is that if you look at the three formulas up at the top of your paper, there's a square root in the problem, so it's got to either be arc sine or arc secant. And it can't be arc sine because the formula for arc sine is the square root of the constant squared minus the variable squared. But we have the variable squared minus the constant squared in this problem. So u is always, the e to the 2x is u squared. So u is just e to the x. All right, and therefore du has to be e to the x dx. Okay, I can stick an e to the x in. What I can't do is put a 1 over e to the x outside, but I could put it on the bottom in the inside. Okay, I've really just multiplied by 1. You can't put a variable, you can't pull a variable in or out of the integral, and e to the x is a variable. All right, so let's fill in our u, and what would a be? 1. All right, so e to the x dx is my du up on top, or I can do 1 over and move the du out there. E to the x is u, and then I have the square root of u squared minus a squared. And voila, that is exactly the arcsecant formula. Isn't that cool? I don't impress Harry very often. All right, and then the arcsecant formula is 1 over a, so 1 over 1, arcsecant u over a. Technically, it's the absolute value of u over a, but u is e to the x. So do I need the absolute value? Nope. Let's see. And I really don't need all those 1s, so I could just say arcsecant e to the x plus c. Okay, that's as hard as it gets. All right, number 4. The problem with number 4 is that the bottom looks like what? Arc sine. Okay, the bottom looks like arc sine, but the top of arc sine is just supposed to be du, and you've got that x plus 2. We've got 2 things on top and really just 1 term on the bottom. So what can I do? Separate the numerator. Very good. All right, so I'm going to separate this into x over the square root of 9x squared plus 2 over the square root of 9x squared, and I'm even going to pull that 2 out and do 1 over the square root of 9x squared dx. Now, which one is an arc sine? The first one or the second one? The second one. Why? What makes the first one not an arc sine? That has an x on top. Okay, so we know the second one's an arc sine, so I'm going to kind of leave that alone for the time being. So how on earth are we going to integrate the first one? Okay, let's go back to the first day of u substitution when we let u be something that's under a radical or in parentheses. So just integrating this very first one, I'm going to let u be 9 minus x squared. So what's du? Negative 2x dx. Can I make the top into that? Absolutely. I need a negative 2 and therefore a negative 1/2. So I have negative 1/2 integral of 1 over root u, so u to the negative 1/2 du. I'm going to go ahead and finish this off. What do I get when I integrate u to the negative 1/2? Okay, 2u to the 1/2, but if I multiply that times a negative 1, I'm just going to get, or negative 1/2, I'm going to get negative u to the 1/2, which is negative 9 minus x squared to the 1/2. No, the first part of that is not any arc.
Why can't we do that with the other one too? Like I said.
Because what's the derivative of 9 minus x squared? Then you need an x on the top. Okay, so for this other part, your u would be x, and du is dx, and what's a? 3. And it's an arc sine, and arc sine is just arc sine u over a. But I do have this 2 right here. So it's 2 arc sine x over 3 plus c. Okay, number 5. 3x cubed minus 2 over x squared plus 4. Long division, very good. How do you know that we need to do long division? Okay, because the degree of the top is bigger than the degree of the bottom. I'm going to do 3x cubed plus 0x squared plus 0x minus 2. And I'm dividing by x squared plus 0x plus 4. What do you have to multiply x squared by to get 3x cubed? 3x. Multiply the 3x through, so 3x cubed plus 0 plus 12x. Change your signs. And we're left with negative 12x minus 2. Do I do another round of long division, or is that my remainder? That's your remainder. Good, because as soon as what you have over here on the bottom, the degree is smaller than what you're dividing by, then that's your remainder. All right, so this whole thing can be rewritten as the integral of 3x plus the integral, basically it's 3x plus the remainder divided by x squared plus 4, so I'm going to break it up into 2 different integrals. So negative 12x minus 2 over x squared plus 4. I just think it's easier. The 3x is something I can very easily integrate, and so I'm just going to... All right, so the integral of 3x is 3/2 x squared, right? Okay, the x squared minus 4 on the bottom. My first thought is, let's let the bottom be my u, because then I could maybe use a natural log integration if my bottom is u. But what is the derivative of 2x plus 4? I mean x squared plus 4. 2x. That's not going to work. Good. All right, what you want to think of, but this x squared minus 4, or sorry, x squared plus 4 on the bottom could be arctan. Good. So let's separate the numerator, but keep that x squared plus 4 as one big quantity. So I am going to do plus the integral of negative 12x over x squared plus 4 minus 2 over x squared plus 4, but I'm going to pull the 2 out. I could have pulled the negative 12 out too.